If you built an AI app in 2024, you probably followed a familiar pattern. You took a large block of text, pasted it into an LLM's prompt window, and asked the model to process it. That approach creates an amnesia loop. Every time the workflow triggers, the AI starts with a blank slate. If your application needs to reference a user's purchase history or an internal company policy, you have to send that exact same data back to the LLM, paying API fees to process the identical information 50 times a day. To build autonomous memory, developers are moving to the 2026 agent stack, broken into 3 layers. The IDE layer is where you write code. The orchestrator logic engine routes tasks. Finally, the vector database stores embeddings for long-term memory, eliminating redundant API calls. Across these 3 layers, there are over 50 distinct frameworks and tools available today. Developers frequently freeze here, caught in a strict trade-off between development velocity, how fast you can ship, and architectural sovereignty, how much control you have over your own system. There is no universal best tool. Choosing the correct stack means mapping these tools directly to your current scale, your team's technical skills, and your operational budget. The AI IDE is where your daily work happens. Its role has shifted. Instead of spending hours writing boilerplate syntax, you are now a director, guiding AI agents directly within your codebase. If you prioritize raw coding speed, tools like Cursor or VS Code with Copilot integrate AI directly into a familiar text editor. They predict full blocks of logic and execute cross-file refactors rapidly. The friction comes at the team level. These tools require managing individual developer licenses, and because the AI writes code in isolation, human engineers still have to manually review the resulting pull requests to prevent regressions. Builder.io addresses that silo by acting as a visual AI IDE. It connects UI design directly to production code, allowing product, design, and engineering teams to collaborate in the same environment without constant translation tasks. On the far end of the spectrum are terminal agents like Claude Code or OpenCode. These run directly in your command line. They navigate your repository autonomously and run shell commands. They are model agnostic, but giving an agent terminal access introduces a tangible risk of unintended system changes. Your IDE choice forces a clear decision. You are either optimizing for a single developer coding at maximum speed and isolation, or you are optimizing for safe, visible coordination across a larger team. Once the code is written, the orchestration framework takes over. This is the logic engine handling state management, continuous loops, and conditional branching as your agent operates. This animated graph illustrates LangGraph's node-based execution. Actions are nodes, edges are transitions. It gives you maximum architectural control to define multi-step workflows. But that control requires a steep learning curve. You are responsible for building the connections, scheduling, and infrastructure from scratch. CrewAI offers an alternative structure. Instead of mapping abstract nodes, you define agents as roles, assigning a researcher to gather data and a writer to draft the report, and the framework handles the pipeline between them. The limitation of CrewAI is its memory. It lacks built-in persistent storage for context across separate runs, and it often struggles to route tasks when workflows require complex, nonlinear branching. If writing orchestration code is outside your scope, managed platforms like Nebula and DeFi allow you to deploy agents visually, connecting them to thousands of external APIs in minutes. The trade for that convenience is your code-level sovereignty. You are accepting hard vendor lock-in and relying on their internal logic for how your data is routed. Orchestration presents an unavoidable choice. You can buy deployment speed, or you can build customized logic control. You cannot have both equally. The final layer is the vector database. This permanent memory structure stores your embeddings and ensures your agent never falls back into the amnesia loop. Pinecone is the industry default for a reason. It is a fully managed, zero-operations database that delivers retrieval latency under 50 milliseconds without requiring you to touch a server. The friction with Pinecone is purely financial. As your data volume passes the 50 million vector mark, the hosting costs scale aggressively and can quickly damage an agency's margins. This line chart tracks total cost of ownership. The managed solutions cost curve arcs upward, while self-hosted alternatives like Quadrant remain flat. Quadrant offers an 80% cost reduction, but you take on DevOps maintenance to keep the database running. If your use case requires matching exact terminology alongside semantic meaning, like legal discovery or e-commerce catalogs, Weaviate specializes in hybrid search, combining both methods in a single query. For early prototypes, Chroma offers free local deployment. It is excellent for testing, but its performance degrades severely once you push past 10 million vectors in a production environment. As your data volume grows, the vector database you choose today will become the single largest factor in determining your operational margins tomorrow. Reviewing the tools in isolation is helpful, but the ideal stack only materializes when you apply your specific constraints regarding time, budget, and scale. This flowchart maps 3 distinct blueprints. We start with the velocity stack, designed for solo developers and prototypers who are strictly time-poor. By combining Cursor, a managed orchestrator like Diffie or Nebula, and Pinecone, you trade higher monthly subscription fees for the ability to ship a functioning product in days instead of months. Next is the Sovereign Agency stack, built for optimizers and automation agencies who must protect their profit margins. Wiring OpenCode, CrewAI, and a self-hosted Qdrant database requires heavy upfront engineering time, but yields an 80% reduction in infrastructure costs. Finally, the Enterprise Precision Stack is designed for teams managing massive data scale and strict compliance constraints. Running Builder.io, LangGraph, and Weaviate handles billion-scale retrieval and complex hybrid search, but demands dedicated governance and massive engineering resources to maintain. The core architectural rule is simple. Never optimize for a scale you do not have yet. Identify your immediate bottleneck today, select the stack that solves it, and get to work.